I'm going to work through some right triangle examples here using SOHCAHTOA. So I'll go ahead and write that up here. SOHCAHTOA. Okay. So the first one here, we've got C is equal to 6, which is this side over here. We have B, which is this angle, 65 degrees. And we want to find the rest of these, A, B, and that other angle there. Okay. The first thing we're going to do is we're going to recognize this here is 90 degrees because it's a right triangle. So we can use the fact that these must equal 180 degrees to get this other one right here. So angle A right here is, we're going to take 180 degrees and we're going to subtract 65 degrees and we're going to subtract 90 degrees, okay? And that's going to leave us with angle A right here. So 180, because that's the total, minus 90 minus 65 leaves us with 25 degrees. So we know that this in here is 25 degrees. These three must add up to 180. That's what we did there, okay? So next, we need to get one of these sides right here. So we can use SOHCAHTOA, and it doesn't matter which one we use. We can start with a sine right here. So if we take the sine, and we pick one of the angles here, it's going to be, it's not the 90 degree angles, it's one of these other two angles. So sine of 65 degrees equals, and this is O over H, O over H. So the O is the opposite. So we take the 65 and we look straight across here. We get the small b over the hypotenuse, which was the 6, okay? So now we need to get this b by itself, so we multiply this side by 6, and then we multiply this side by 6, and then these cancel, which leaves us with 6 times the sine of 65 degrees equals small b. So I'm just going to put that right in the calculator. I'm going to go 65, hit sine, and I'm going to go times 6. And I end up with 5.44. So 5.44, and that's what this side is over here, 5.44. Okay, now I could use cosine to get this one right here, cosine of 65, or I could use Pythagoras theorem. So what I want to do is I want to use Pythagoras theorem, just to mix it up a little bit. And that Pythagoras says that a squared plus b squared equals c squared. So if I want to get this worked out, I've got a squared, that's what I'm trying to find, plus b squared, which is 5.44 squared, equals c squared, which is the hypotenuse, 6 squared. Okay? So what I need to do is I need to subtract 5.44 squared from each side. You know, it's plus and minus, so these cancel out. Now I've got a squared is equal to 6 squared minus 5.44 squared. Okay. Now I need to get rid of this squared here. In order to do that, I have to take the square root of each side. Okay, and that will cancel these. So I'll end up with a on this side is going to be equal to the square root of 6 squared, which is 36. 6 times 6 is 36, minus 5.44, and I'm going to go ahead and square that, 29.5936. Okay, so if I subtract these two, 36 minus 29.5936 and hit equals, and I take the square root, I get 2.53. So a right here is 2.53, and you can check it. 2.53 squared plus 5.44 squared, and then you hit equals and take the square root of that, you'll get 6. So that's different ways to do it. You can use the SOHCAHTOA, or you can use a mix of SOHCAHTOA and Pythagoras. Take a look at this one right here. We have a is 8, b is 5, and then we need to find the rest of these. Okay, so maybe the easiest thing to find right here would be the opposite small c using Pythagoras. So once again we've got c squared is equal to a squared plus b squared. So c squared is equal to a squared, which is 8 squared plus 5 squared. b squared. 8 squared plus 5 squared. Remember, we need to take the square root of each side in order to get rid of this right here to get c equal to the square root of 8 squared, which is 64. 8 times 8 is 64, plus 5 squared. 5 times 5 is 25. So c equals the square root of, add those two together, 89. So I go 89, take the square root, I get 9.43. 9.43 is that side right there. Okay. Now I need to get an angle, which means I'm going to have to use an inverse trig function because I've only got one angle here, 90. I don't have either one of these, all right? So I'm going to use, let's, for example, want to use sine, and let's figure out this one right here. I've got b right here. So sine of b is opposite over hypotenuse, which is 5, which is the opposite over the hypotenuse, 9.43. Okay. In order to get the angle, I need to take the negative, the inverse of the sign. That's what that is there. So the way you do that is you're going to take the 5 and divide it by the 9.43. Hit equals, and then you have to take the inverse sine, and that is equal to 51.04 degrees. So apparently this right here is equal to 51.04 degrees. Okay. And then if we wanted to get the other angle, we would just subtract those right here. We could go 180 degrees minus 90 degrees minus 51.04 degrees. That leaves me the remainder. 180 minus 90 minus 51.04 leaves me 38.96 degrees. Okay, so I just did this and it doesn't quite look right to me, all right? I'm seeing that, you know, this side is longer than this one right here, which means that it seems like this angle would be bigger. So I wonder what I did wrong with my math right here, okay? I believe that I've got my side right here. So sine -1 is opposite 5 over 9.43. Let's just check that again. Inverse sine 32. Haha. I made a mistake here. Sorry. Sine of 5 over 9.43 is 32.02 degrees. My bad. Okay. Well, what I did is I looked at my answer and it didn't really make sense when I looked at it because, you know, you'd expect the smaller side with a smaller angle. So now when I run this again and I put in these new values, I think I'm going to get something better. 180 minus 90 minus 32.02. I get 57.98. Okay, that's definitely looking better. 57.98 degrees. So there you go. And then these all in here add up to 180 degrees, right? So this was 57.98 degrees. There and there. All right, little mistake there, but we use a little intuitive thinking to figure out that we had made a mistake. As long as we're thinking about intuitive, let's take a look at this one right here. So notice that this one, just by looking at it, it doesn't seem right. It says this side is 9 and this side is 12, but this side certainly looks longer than this side, okay? So that's telling me that this triangle is not drawn to scale, but we're going to go ahead and we're going to run these numbers based on what it says, not how it's drawn, okay? So same thing we would expect, because this is 12, that this angle to be larger and this angle to be smaller, even though it's not drawn that way, all right? We're going to run with the numbers, not the picture. So we want to get an angle. Let's say we want to get this angle here, and we can use SOHCAHTOA again, and we can take the sine of A is the opposite over the hypotenuse, which would be 12 over 15. In order to get that, we have to take the -1. That's going to give us that angle. So if I go 12 divided by 15, and I hit inverse sine, I get 53.13 degrees. Okay, so this is 53.13 degrees. Now, let's go ahead and get this sine B. We could certainly subtract 180, take 180 and subtract this, and then 90 would give it to us. Let's just do SOHCAHTOA again on this. So here's B. Sine of angle B is once again the opposite. The opposite of this is 9 over 15. Okay, and if I want to get that, I got to take the inverse of it. And so if I go 9 divided by 15 in second function sine, I get 36.86 degrees. And sure enough, this is 36.86 degrees. These all add up to 180. These sides, if you went 15 squared and took the square root of it, you would find that 9 squared plus 12 squared equals 15 squared. So Pythagoras Theorem would work out for that as well. Okay. Got quite a few more to do here. We'll practice. Use Pythagoras to find the third side. So the third side is easy here. We know that we have 15 squared plus 20 squared equals c squared. In order to do this, we have to take the square root of this so that we end up just with c, and we have to take the square root of this side as well. So 15 squared plus 20 squared equals c. So we know that 15 squared is 225 plus 20 squared is 400. So it looks like the square root of 625 is going to be equal to c, right? You can always just do it this way. 15 x squared plus 20 x squared hit equals, and then there's 625. Take the square root, 25. So we know that this is 25 here. Now we need an angle. So we can use SOHCAHTOA. SOHCAHTOA. Okay. And what that is doesn't matter. We can maybe try the tan. We want to do this angle right here. Tan of angle A is opposite over adjacent. 15 over 20. In order to get the angle, we got to do -1. So I come here and I go 15 divided by 20. Inverse tan, 36.86. I get 36.86 degrees. How about this angle B right here? Well, we know that these have to equal 180. So I could certainly go 180 minus 90 minus 36.86. Okay. 180 minus 90 minus 36.86 gives me 53.14 degrees. So that's another way to do it that way. Okay, let's do another one here. Subtract the two sides. So looking at this right here, the thing that really jumps to me is that we can get this other angle here just by subtracting 180 for all of these. So we subtract the 90 and we subtract the 51 degrees. Gives us 180 minus 90 minus 51 gives us 39 degrees. So here's my 39 degrees here. Okay. And then now I need to get one of the sides. So I can use my trigonometry. And so what do we want to use? We can use sine again, opposite over hypotenuse. Doesn't matter which one. Let's do sine of 39 degrees right here equals the opposite over the hypotenuse. Opposite to this is A. Hypotenuse is 26. Okay, so we need to multiply both sides by 26 in order to get rid of it. Okay, so we got sine of 39. That's sine times 26. And that's my A, 16.36. Okay. We can certainly get this side right here by using the cosine. The cosine of 39 degrees. And it's not the opposite over the hypotenuse, it's the adjacent over the hypotenuse, which is going to be b over 26. So instead of a over 26, it's b over 26. Same thing, you need to multiply each side by 26. So we got 26 times the cosine of 39 is going to be equal to the b. Okay, so 39 cosine times 26, 20.2. 20.21, so that's my side right there. Okay, and you can do Pythagoras and it would verify it. Got another one here. Inverse trig to get the angles. So we've got all the sides, we just need the angles. And so we can pick this angle right here. And if I have all these, a lot of times I just like to use the tan. Tan equals the opposite over the adjacent. That's tan is TOA. Tan is opposite over adjacent, which is equal to 7 over 24. Okay, that will give this one here. We need to take the -1, the inverse of this, to get the angles. When we're solving for angles, we take the inverse. So I get 7 divided by 24, I'll hit equals. I have my inverse, tan, and I'll get 16.26 degrees. I could do 180 minus 90 minus 16.26 to get this. I could also just take this angle here, and this was tan of A, by the way. I could take tan of B. Tan of A was 7 over 24. Tan of B is opposite over adjacent, 24 over 7. Okay, and if I take the -1 of that, 24 divided by 7 equals inverse tan, 73.74 degrees. That's what this is, 73.74 degrees. And you can see that these all add up to 180. Keep rolling here. Look at this. TOA. All right. Use SOHCAHTOA to find the other side. So I got all my angles. That's looking good. I can't use Pythagoras because I don't have another side. What I can just do is use SOHCAHTOA. So let's pick 32 right here. So sine of 32 is equal to the opposite over the adjacent, or opposite over hypotenuse, is equal to A over 30. And you can multiply this side by 30, multiply each side by 30 to get rid of it. So I got 30 times sine of 32 equals A. So 32 sine times 30, 15.898. 15.898. That's what this is over here. Okay. How about B right here? Well, we could just use cosine if we wanted to. Cosine of 32 is equal to adjacent over hypotenuse. That's the opposite. So this is the adjacent, which is going to be B over the hypotenuse 30. Multiply each side by 30 in order to cancel. 30 cosine of 32. 32 cosine times 32 is 27.14. And Pythagoras would prove that would be true. Okay. Next, we're going to plot the following as radians. Okay. So angles and degrees. So angles can be designated in any one of these. So if we take a look at 360 degrees, we don't know what that is in radians. We're going to have to do a little math here to get these as radians. Okay. This one right here just gave us as 2 radians. Okay. As angles, all right, so this one just gave us that it was 360 degrees, and this one just gave us that it was 180 degrees. And angles and degrees, and angles in terms of pi, okay? And so it gave us this one is pi over 4, okay? So we're going to need to fill in the charts for the rest of these, all right? So first of all, this column here is radians. So to get radians from degrees, to change from radians to degrees, we multiply 100, we would get our pi here first. But no, okay, multiply 180 degrees divided by pi, okay? So what we're going to do is we're going to take 180 divided by pi, divided by pi right there, okay? And so I got 57.29, okay? And that is 57.29 degrees per radian, okay? Is when we're changing from radians to degrees. And so if I have 2 radians right here, let's actually we can do this one first right here. 2 radians, so we got 57.29 per degree, and I've got 2 of them, so I'm going to multiply this by 2. So this 2 radians is 114.59 degrees. All right. Let's work back here. 360 degrees, 2 degrees from radians. We take pi divided, we just take the opposite of that. We take pi divided by 180, and we got 0.0174. Okay, and that's what you get here, 0.01745. Okay, so we're going to multiply that by 360, and we get 6.28. So this is 6.28 radians. Okay, 180 is going to be half of that. Obviously half of that. So and to divide that by 2, I get 3.14 radians. Okay, so maybe the next thing we need to do here is figure out what pi over 4 is. Okay, so when I look at my chart here, I have 0 to 180, and then 180 to 360. Well, this is pi, and this is 2 pi right here. Okay, so 360 degrees is 2 pi, 180 degrees is pi. So we're getting our chart filled in here pretty well. Okay, and then so we have pi over 4. So here's pi. This over here is pi over 2, and then divide that in half, and we're going to be over here at pi over 4. Well, this is 180. Half of that is 90, and so pi over 4, this is going to be 45 degrees right here. Okay, 45 degrees. So if we take these radians right here, we wanted to do this again, pi divided by 180, and then we want to multiply it by the 45 degrees. We get 0.785 radians. Okay, and finally we have 2 radians, which was 114 degrees, which it's kind of in here somewhere if you were looking at this, 114 degrees. So what is that? That is going to be a little ratio here. We get 114.59. This is a hard one. 180 degrees is pi, so we're just going to take the fraction of that right there. Okay, so I get 114.59 divided by 180. I get 0.636 pi. So this is 0.636 pi. Okay, so what we're going to do is we're going to look at our chart here and see it. 360 degrees is 180, 360, that's a full circle. And you can see right here it says 6.2, 6.1, 6.2, 6.28. These are my radians. It looks like 6.28 radians is about where we're at there. So 360 degrees is 2 pi, 6.28 radians. 180 degrees is half of that, right? Half of that, which would be, when you look up here, here's my radians, 2.8, 2.9, 3.1, 3.14. There's my radians, 180 degrees, and that's called pi. If I picked 45 degrees right here, that is going to be 45 degrees. It's going to be pi over 4. Okay. We saw that 1 radian was 57 degrees. So we're not even to 1 radian. 1 radian would be up here at 57 degrees. We are at about 3/4 of a radian, 0.785 radians, 45 degrees, pi over 4. And the last one we did is we did 2 radians, where we took the 57.59 and we multiplied it by 2. We got 114 degrees. So that would actually be, you know, maybe in here somewhere. Okay, that's where that would be. And so that's obviously more than 90 degrees. And if you do the degrees here, it looks like it's about 114.59 degrees. And if you were going to do pi, well, here's 1 pi. It's not 1 pi. Here's pi over 2. It's greater than that. So it's about 0.636 pi. So that's how we put those degrees, or we put those angles, we plotted them as radians, angles in degrees, and angles in terms of pi.